Hello everyone. Welcome to this webinar on data mesh and why federal agencies should be early adopters of this promising new approach to data management. My name is Cindy Walker. I'm a vice president with Octo Consulting and I lead our Data Management and Analytics Center of Excellence. I'm joined today by Rohini Krishnapura, a senior technical product manager with AWS. Rohini and I have been collaborating for the past several months on data mesh solutions for federal clients, and we're very excited to share our key lessons learned and describe the value proposition we believe data mesh offers for federal government organizations as they strive to overcome limitations of the traditional approaches and transform into data-driven enterprises to achieve their aspirational data goals. In this webinar, we will discuss why federal agencies need data mesh, and we'll describe what data mesh is and what it isn't. We will explain the benefits of being an early adopter. Rohini will provide an example of how to design a data mesh platform, and we'll wrap up by providing a roadmap for how to get started with execution. We prepared this webinar and organized it this way because we have observed that most federal government organizations want to drive innovation and become data-driven, and many are making huge investments in machine learning and artificial intelligence capabilities to support the use of data analytics for their data-driven decision-making. Yet, many are still struggling to source, manage, access, and protect trustworthy analytical data at scale. As a result, most are not realizing maximum value from their significant and ever-increasing investments in data analytics, and their data value to investment ratio is low. This very disappointing return on investment is not due to an absence of high-level support within the organization. In fact, in most federal agencies, it's the chief data officer or leaders at the highest levels of the organization pushing for the change needed to accelerate innovation and realize data advantage. We believe the reasons for the disappointing results with traditional approaches share common failure patterns that data mesh is intended to address. Let's explore why a federal government organization might need to consider a paradigm shift to a different data management approach, and why we believe it's the data mesh approach they should adopt. The primary reason is that for many federal organizations, the status quo is just simply not working. They are large and complex enterprises, and many exhibit common failure patterns that data mesh is intended to overcome. In fact, as I've observed for over 4 decades, federal government organizations have expressed a desire to treat data as a strategic asset, to manage it, share it, and analyze it, and exploit it for mission advantage. And in recent years, most have developed elaborate data strategies and used terms like data-centric, data-driven, data-aware to describe their target state vision. And certainly evolutionary progress has been made, mainly centered around technological advances with big data platforms and data fabrics. Yet today, most enterprises have not progressed very far down the road toward their desired data-driven state. The enhanced impact they desire is reflected on the y-axis of this chart. They want greater value from data, agility, immunity to change in the face of ever-increasing complexity. The challenges they face in terms of increasing scale are reflected on the x-axis in this chart. Certainly they're seeing increasing complexity, increasing proliferation of data sources, exploding increases in the demand for data to fuel AI and ML use cases. And many are at the inflection point you see in this chart, where if they continue their current approach, they'll continue to struggle to achieve those desired impacts. Whereas if they pivot to a better approach, they can begin to see change. So what are some of the common characteristics in the status quo we're observing? Certainly, many federal agencies have heavy technology investments in data-focused technology. Most have embraced data lake-based data platforms with single monolithic centralized data lakes and single monolithic data platforms, which has really resulted in the reality of what we call request and wait, where the data consumers are asking the data providers or going to the platforms to try and get the data they need. And if it's not there, it takes a while to get the data available to fuel the analytics needs. As a result, we're not seeing the ambitious data aspirations being achieved, and many are not realizing that expected data value. So for an example, we work with a major defense organization, and they have invested over $750 million in a single centralized traditional big data platform solution. Yet in the last 2 years, that investment has happened over the last 2 years. But they've also very recently expressed concerns that it is extraordinarily difficult for them to discover and use data as an on-demand asset seamlessly across their data domains, such as cyber, logistics, weapon systems, and intelligence. And they've acknowledged that the pace of the evolving threat landscape mandates a change in the culture as well as their operational construct for how they manage data across their mission areas. Those mission areas have a natural convergence that requires that data sharing. And they've acknowledged they need to fundamentally transform their approach to data governance and data management. So if the status quo is unacceptable, what are some of the root causes of the failure? And these are some of the failure patterns that we're seeing. The centralized monolithic data architectures introduce latencies and friction and delays. Centralized teams of data specialists who are separate from the business domain where the subject matter experts are creates a schism between the folks who have the data knowledge and the business context understanding and the folks who are actually doing the data management activities like the transformations. This focus and this approach that's very heavily focused on collect and transform rather than serve high value doesn't yield the maximum mission value. So, Zhamak Dehghani of ThoughtWorks began evangelizing the concept of data mesh back in 2019, about 3 years ago, as a paradigm shift that was needed to overcome some of the limitations we just talked through that federal agencies are facing and commercial enterprises as well. And she's addressed the failure modes of those traditional approaches. She's since written a book. It's a great reference for data mesh adoption. And the focus of data mesh is to really help complex organizations like federal government organizations realize the outcomes that making that paradigm shift can achieve. Increasing value from data at scale, sustaining agility, embracing change in the face of complex, volatile environments. Data mesh is a new approach to collect, manage, share data for analytical use cases at scale. It's not a tool, it's not a product you can buy. It's a socio-technological approach to data management grounded in lessons from distributed architecture, microservices, and product thinking. And it's an approach that enables a robust, governed data product marketplace where data providers and consumers can interact directly. When I first read Zhamak's original data mesh blog post and I began to understand what data mesh is, it immediately resonated with me, having helped federal government organizations struggle for many decades to address some of the failure patterns of the heavy centralized monolithic approach. And to be honest, it more than resonated. I felt like I had been struck with a lightning bolt. And I had this sort of combination aha and duh moment, because the shifts data mesh requires are so obviously needed, and yet they challenged so many of the long-held tenets of data management that had just been accepted for so many decades. Data mesh promotes change in all the areas that were simply not working well in traditional data management approaches, from centralized ownership of data to decentralized domain ownership, need to make the shift from focusing on data as a strategic asset to collect and manage data as a high-value data product to be shared, to delight customers, not just to be collected into a monolithic data lake. By making these shifts, federal government organizations who have been struggling to get value from data at scale or not achieving their aspirational data goals can overcome those failure patterns of traditional approaches. These four simple principles underpin data mesh's logical architecture and operating model. They're designed to help complex organizations achieve the outcomes. First, the principle of domain data ownership. Decentralize the ownership of analytical data back to the business domains that are closest to the data and decompose the overarching data logically based upon those business domains. And it enables those domains to manage the life cycle of the data within that domain independently. So it's very much a decentralized federated approach. And really very importantly, it architecturally and organizationally aligns business technology, analytical data with the business outcome that the domain is focused on achieving. The status quo, alternatively, in many federal government organizations is the exact opposite of this principle. The emphasis there is on data being an enterprise-owned, and although many have domain data stewards responsible for quality of the data, most do not have those domain data stewards responsible for thinking about the consumer and providing high-value data products, end-to-end data products that delight those customers. Enterprise ownership focus resulted in really that schism between the domain experts who understood the mission context and the business objectives and a centralized team of data specialists who performed all the data management functions. So this data mesh principle closes the gap between the real origin of the data and where it's used for analytical use cases. Second principle of data as a product enables those domain data-oriented teams and that domain data to be shared as a high-value product directly with data users. Consumers of all types, analysts, data scientists, etc. Data as a product introduces a new unit of logical architecture called a data quantum, controlling and encapsulating all the structural components needed to share data as a product. That means the data, the metadata, the code, the policy, and the declaration of infrastructure dependencies autonomously. So each data product provides a set of explicitly defined and easy to use data sharing contracts. Each data product is autonomous and its life cycle is managed independently of others. It removes the possibility of data silos by making data as a product that teams share, because that's the whole purpose, rather than as an asset that is collected and siloed. It streamlines the experience of discovering and using high-quality data peer-to-peer without friction. The third principle of self-service data infrastructure as a data platform introduces a new generation of data platform that empowers those domains' cross-functional teams to share data within a domain and across domains. The platform services remove that friction from the end-to-end journey of data sharing, and the services manage the full lifecycle of individual data products, streamline the experience of data providers to build, deploy, maintain data products, and also streamlines the experience of data consumers to discover, access, and use data products. It abstracts complexity, it reduces the cognitive load of those domain teams required to manage their data products. The last principle of federated computational governance creates an operating model based on federated decision-making, and it balances the autonomy of the domains and the agility of the domains with the global interoperability concerns across the whole mesh at the enterprise level. It relies on codifying and automating the enforcement of those policies at a fine-grained level within every data product via the platform services. These four core principles all complement each other, and they each address new challenges that might arise from the others, as shown by this chart. It's an example of interplay among the principles. So for example, decentralized domain data ownership of data can result in data siloing within domains, and this can be addressed by the data as a product principle that demands that domains have a responsibility to share their data as high-value products, both inside and outside their domains. Similarly, the domain ownership of data products could lead to duplication if not supported by the services of the self-service data platform. And that platform empowers those domain teams to easily share and use data products, and it empowers the data consumers to easily discover and understand and access data products. So when you put it all together operationally, you can envision the principles in action as shown here. This is a defense organization example of a simplified data mesh operating model. The colored ovals represent mission domains, so we've got recruiting, military readiness, and military personnel member domains represented here. If you look within each of those big ovals, within each domain, you see the cross-functional teams represented. They're comprised of data SMEs, data engineers, and developers, generalized developers. They're achieving the business objectives of the domain because they understand that, that's their focus. And they're using digital applications and analytical data products to do that. So for example, if you focus on the recruiting domain in the bottom left, has a business objective to improve recruiting performance. And they have a recruiting tracking application to help achieve that objective where they're actually enrolling recruits, as well as a data product, a recruiting daily snapshot to keep track of how many and what types of recruits they're recruiting each day. Now, if you look to the right, the military member domain is a consumer of the recruiting daily snapshot data product because its business objective is to develop skills of those recruits and to transform them into viable military personnel who can perform military missions. And they produce a data product to track their military personnel record of each person. So global policies that you see represented in the federated computational governance umbrella that sits on top of all this apply to all data products in all domains. So for example, both of these data products contain personally identifiable information, PII. So there's a global PII policy that's established and is enforced within each data product in an automated way via capabilities that the self-service data platform automates, such as access control, to ensure that the PII attributes of the data products are managed in accordance with that policy. Characteristics of a data mesh operating model enable the organization to realize more value from data and scale to meet operational demands. Those characteristics include having and supporting a data-curious culture. Characteristics of a data mesh operating model shows high value from this network sharing effect. So basically you get compound value as each domain shares its products in the broader network of consumers. You get limitless scale of autonomous data products because each domain can be independently, simultaneously developing and serving up and consuming data products. And because you've embedded this partnership with AI and data within a domain, you again are able to scale and provide high value products. So the promise of data mesh for federal government organizations is significant, and most stand to benefit from pivoting from whatever current approach is to data mesh as soon as possible. It's important to note that data mesh is still in the early adoption phase, as shown here in terms of E.M. Rogers' diffusion of innovation S-curve. So truthfully, the concept is nascent, and the organizations are still exploring how best to adopt and operationalize the mesh principles. It's been exciting to watch, especially over the past year, how many technology providers have leaned in to demonstrate how their data management and analytics tools can be used to enable this new paradigm. And so why are we encouraging federal government organizations to be early adopters? Well, in a nutshell, in most cases, the benefits of being an early adopter for a federal government organization outweighs the risks for the reasons shown here. First and foremost, the status quo is not working, as we discussed earlier, and continuing down the current path is certainly not going to yield the desired results. There's a low risk to adoption because adopting these principles primarily requires an organizational shift, especially initially, in distribution of people resources, not necessarily additional resources. It also doesn't require necessarily any major technology acquisitions or major application redesigns. And also, in many cases, there are building blocks already in existence, such as established data domains that can be leveraged to support the pivot to data mesh. Being an early adopter means federal agencies can eliminate the central data team, middleman, thereby removing a huge bottleneck. They can embed machine learning and analytics capabilities within each domain, and they can enable peer-to-peer consumption of data for analytical use cases. This strategy also can ensure mission continuity in the face of continuous change by focusing on change locally within a domain. And most large federal government organizations already meet the readiness criteria for data mesh adoption. We'll go into that here. In her book, Data Mesh, Dagani provides guidelines for determining if an organization should adopt data mesh, and you can use these guidelines to self-assess whether your organization is actually ready to adopt data mesh now during this early adoption phase. Using her readiness criteria, shown here, and applying them to our experience supporting federal organizations with their current data management approaches, we truly believe that most federal government organizations meet the readiness criteria for going ahead and being early adopters. That is, they would score high or medium in each of these criteria. They would fall within the area above, in the spider chart you see here above the orange line. So we've ranked them high in terms of organizational complexity. There certainly is a proliferation of data and applications within large, complex federal government organizations. Most have already begun to tackle the technology and business alignment, and many already have established at least data domains that are guiding the modernization efforts. Most have adopted modern engineering DevSecOps practices. We ranked them for our example here as medium there because many are going that direction but may not have completely optimized those DevSecOps practices yet, but we did rank that as medium. In terms of executive support, we're seeing everywhere chief data officers and supporting better ways of dealing with data management and getting data advantage, as well as making huge strategic investments in data. In terms of tech at core, the desire to build tech enablers, because you certainly can't buy an already produced data platform as a tool, we rank that medium. And then in terms of data-oriented strategy, if analytics is a strategic driver, that certainly gets a high ranking in every federal agency I'm aware of. Data analytics is certainly a strategic driver of decision making. And most are ready for transformation. They've expressed a desire for innovation and data-driven value. So granted, this is just a broad brush, high-level assessment, somewhat subjective, based on our experience, and each organization needs to make their own self-assessment determination. One area that may give federal government organizations pause in the pivot to data mesh is the self-service data platform core principle. So we wanted to dive a little deeper into this principle by explaining the characteristics of the data mesh platform and the capabilities the platform should enable. because it's really a big departure from how current big data platforms are deployed in the traditional data lake platform centralized model, although many of the same tools can be used to implement the data mesh-based platform. So traditional platforms typically have a single data lake and a single monolithic data platform. These architectures are problematic because in most cases they introduce a friction and delays meeting consumers' demands for data. And they don't promote a thriving peer-to-peer data marketplace with a provider and consumer being able to directly connect. So the characteristics of a data mesh platform, it needs to be able to serve these autonomous data-oriented teams. It needs to make it very easy for them to, in a self-service way, manage and create those interoperable data products with all of the components of that data quantum, which includes the code, data, policy, metadata, controls as one consumable, discoverable unit. It needs to provide that continuous connection of the operational plane of data and the analytics plane of data. It needs to be designed to support a generalist majority, meaning it should not require highly specialized data tool experts. The general developers should be able to use the platform. It should favor decentralized technologies and should certainly provide all capabilities that are domain agnostic, meaning that are required by all domains to execute their responsibilities. So on the left, you see the capabilities of the platform. You see this is basically a reference architecture representing how to think about the logical capabilities that the data mesh platform should provide. You see there are 3 experience planes, and within each of those planes there are bubbles, and you see some representative capabilities. So at the data infrastructure plane would be capabilities for data storage and the networking and the access control. Most of that functionality is available in the current platforms, and certainly there's a wide variety of tools that enable these capabilities. The middle layer, the data product developer experience plane, is really new. It's not happening in traditional platforms where domain owners of data products and developers can actually build and declare those data products, and where consumers can read the products. And the top level, the mesh experience plane, enables the enforcement and the management of those global policies that get to be enforced at all data products, as well as the discovery capabilities. Now, there's a large body of technology solutions that fall into the category of data infrastructure, and they're often posed as platforms, such as data storage, for example, data lake or lakehouse, data processing framework and computation to process data in batch or streaming modes. You've got data cataloging to enable discovery and data pipeline workflow management. So many of these capabilities are certainly still needed to enable the mesh platform as we've described it here and as Dagani describes it. However, there's a major shift in approach and objectives in the data mesh-based platform because it enables those domain data teams to manage data end-to-end, closing that gap between the operational and the analytical planes, and so that the mesh platform has to be able to provide a more connected experience. It's got to enable the operational technologies and analytical technologies to work seamlessly together. And so there are many different alternative solution architectures and combinations of existing enabling tools that can deliver these platform capabilities. It's also possible to leverage existing cloud native and analytics services such as AWS to enable the self-service platform. And Rohini is now going to describe an example of how to do that. Over to you, Rohini.
Hey everybody, I'm Rohini Krishnapura. I'm a Senior Technical Product Manager at Amazon. Now that we heard from Cindy about what a data mesh is and what its benefits are, let's talk about how to go about building a data mesh architecture on AWS. So let's look at AWS Analytics services to look at how a data mesh can be facilitated. Let's consider one domain on the mesh. If each domain is considered with a blueprint of a modern data architecture, the AWS Lakehouse architecture, This gets data closer to the services that use it. Purposeful databases like NoSQL database or bringing machine learning for insights closer to the data. So this modern data blueprint or architecture pattern brings about a domain-centric approach where each organization can scale within this data lake to effectively maintain and manage their data. Data movement is also easier to facilitate with this pattern where each organization can maintain their data, sharing among instances. Governance of maintaining this data is also easier where authorization and permission of data in the lake and other instances is facilitated within the domain. And all of this is performant and cost effective. So really to build this data lake, Amazon S3 is the standard recommendation. It's durable, available, and a scalable storage service. Within Amazon S3, there are many storage options and archiving capabilities. It's cost effective, there's encryption, it has security, compliance, and audit capabilities. So it's really well placed at the center of this pattern. The other aspect to highlight in this architecture is the AWS Lake Formation, where you can build, manage, secure, and share data inside your data lake. For example, to bring data in, you can have an ETL workflow built with AWS Glue, and you can build a catalog of data sets. You can search this data, transform this data, run Amazon SageMaker to run machine learning models on this data. You can secure access. For example, you can secure S3 access managed by resource permission. Lastly, you can also use serverless options like Amazon DynamoDB, Amazon Aurora Serverless to scale capacity on demand based on the application's needs and be efficient on usage and thus lower costs. So now let's consider one example of a data mesh in action and how these data personas, the data producers and data consumers, come together on the mesh. Of course, data consumers can become data producers and vice versa, but for the purposes of this illustration, we'll keep them separate. The pattern that you see on the slide is the federated data governance facilitated from a central account or the centralized organization, the box in the yellow. And the data producers are the boxes in green depicted on the left side. And really, they're a mix of data stewards and data engineers as the personas. These users own the data that they bring in and are responsible for the pipelines and really for the full cycle of the data. They can ingest the data into S3 buckets through pipelines that they own, operate, and maintain. If there's on-prem data, AWS DMS, data migration services, can help migrate data to AWS quickly and securely. You can ingest your data from the most widely used commercial and open source databases. So you can have an ETL workflow built with AWS Glue, and data engineers can build a catalog of the data sets they own. This catalog of data sets helps to make them discoverable and accessible by consumers. They can publish metadata about their data to facilitate this understanding of data. This enables that data discovery for consumers who we'll talk about next to find and request that data. Lastly, producers can also control access to the data through a federated data governance model to manage and remain in control of data shares for the data that they own. Now let's look at data consumers on the mesh. Think of a data scientist, an analyst, or a researcher looking for that data to build a model as examples for data consumers. This is the blue box that you see on the screen on the right side of the screen. This data consumer finds and requests access to the data product. Now, since data producers in each domain maintain a data catalog of their respective registered data sets, there's a central data catalog that is maintained and kept in sync for search and discovery of data to be realized. So once that data share request comes in, the request is passed on through the federated data governance to the data producer or data stewards who own the data and have control on data access and be able to grant access to the data to the rightful consumers. So once the data request is approved, the consumer can now use that data to apply downstream services on this data, like Amazon SageMaker to build and deploy machine learning models, use Amazon Athena to run queries, or use services like Amazon Redshift to get analytics at scale from this data. Now we briefly looked at one pattern where AWS can help realize data mesh benefits and see that interaction between data consumers and producers. This facilitates the data discovery, domain authority, and accessibility of that data all through the federated data governance to control, manage, and audit permissions. This helps avoid data silos and for organizations to extract value from their data. Although we talked about one design pattern for a data mesh on AWS, I've linked in resources to explore other possible architectures that may be suitable for your own organization. And now that we've explored how to build a data mesh architecture on AWS, let's see how to get started with execution from Cindy.
Thank you, Rohini. That's a great deep dive into how to design and begin evolving that data mesh platform. So now let's zoom out and talk about how to begin executing the data mesh approach overall. At the center of this slide, we've represented the 3 core data mesh outcomes that we've reiterated throughout this webinar. And around the circle, we show the execution imperatives that are required to achieve each outcome. Of course, data mesh is a component of your larger enterprise data strategy, and it must be implemented in an evolutionary manner driven by business-driven use cases. And those use cases need to guide the identification of the data products, and then therefore the components of the data platform needed to build and manage and consume those data products. You can start small with one domain and a few key source-aligned data products within that domain and evolve from there. Your execution roadmap should ensure that you take every opportunity to embed product thinking everywhere. It's a key way you're going to be able to increase that ratio of value from data to your investments. For example, if you have domain data stewards, you should begin to introduce the concept of data products and data product ownership. You should also start to pivot to introduce capabilities of the self-service data platform, such as those Rohini just demonstrated, and they should be prioritized to roll out the capabilities most needed to address your particular needs and evolve. For example, we have found it very effective to prioritize the mesh level experience plane data product discovery capabilities of the platform. And that allows you to have empirical evidence that demonstrates a decreased time and reduced latency and delays, reduced delays to discover, understand, and acquire data products for use. To sustain agility, your execution strategy should remove all centralized monolithic bottlenecks and enable domain autonomy. And you can do that by redistributing resources from your separated centralized data team to support the domain-centric cross-functional teams. Business-driven execution flows, similar to how Amazon approaches building their major products and initiatives, start with the customers and work backwards, is the way to go. Execution should be incremental and iterative. Evolutionary execution lowers risk and incrementally moves you toward your target state. Thank you all for taking this journey with us today as we've described data mesh and explained why we believe federal government organizations should pivot from the traditional approaches to data management to adopt data mesh now. So here are the key messages we'd like you to take away from the webinar. Data mesh is a new approach to data management. Early adoption can yield significant benefits for federal government organizations. We believe most meet the readiness criteria to be early adopters, and they can take a low-risk evolutionary adoption strategy and execution approach. AWS offers cloud-native services to enable high-value evolution of your data mesh platform. We hope you'll reach out to us with your feedback and questions, and we'd love to hear about your data mesh journeys. Here's my contact information. Thanks again for joining. I look forward to hearing from you.